In differential geometry of curves in space, three vectors are called fundamental vectors. These vectors are tangent, principal normal, and binormal. We already know that if C be a space curve with two neighboring points P and Q on C, then tangent at P is defined as limiting position of secant PQ when Q tends to P. For curves in space, at each point radius of C, there is a unique tangent vector. In this video, we briefly describe about the fundamental vectors. Let C be a space curve and P be a point on it. The normal line at P is a line perpendicular to the tangent at P. For three-dimensional curves in space, there are infinitely many normal lines at a given point on a space curve. Among such infinite normal lines, two normals are of special importance. They are principal normal and binormal. In the figure, you can see there are infinitely many normal lines which all are perpendicular to the tangent at a given point. The black arrow is a tangent line and all red arrows are the normal lines. Let C be a space curve and P be a point on it. Then principal normal at P is a normal lying in the osculating plane at P. In the figure right side, P is a point and the shaded part is the osculating plane at P. And now, the normal which lies in this osculating plane is called principal normal. We denote the unit vector along this normal line by vector n. We already know that the unit vector along tangent is denoted by t vector. Similarly, the unit vector of principal normal is denoted by n vector. Let C be a space curve and P be a point on it. Then binormal at P is a normal which is perpendicular to the osculating plane at P. In the figure alongside, the shaded portion is osculating plane and the binormal is perpendicular to this osculating plane. We denote the unit vector along binormal by vector B. The three unit vectors t, n and b are called fundamental vectors. These vectors exist at each point on the space curve. Therefore, they are called fundamental vectors. These vectors move along the curve, so t, n and b are also called moving trihedrons. These vectors are mutually perpendicular to each other, so T, N and B are also called orthogonal triads. In the video alongside, you can see the moving trihedrons which move along the curve. These three vectors T, N and B move along positive directions and satisfy the relations. Here T dot T equals to 1, N dot N equals to 1 and B dot B equals to 1. Also T cross T equals to 0, N cross N equals to 0 and B cross B equals to 0. Also T dot N equals to 0, N dot B equals to 0 and B dot T equals to 0. Also, T cross N equals to B, N cross B equals to T, and B cross T equals to N.